All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are honestly, I don't know if we're gonna do Godot stuff today or if I feel like diving into the Polar's library on either the Python or the Rust side. I'm gonna say we're gonna be learning Godot, and we're gonna continue learning Rust scripting for Godot. And then let's see, once I finish my YAP session, my initial YAP session that I do at the beginning of the stream, once I finish that, let me see if I end up getting distracted enough that we eventually just move over to doing Polar's stuff today, and push Godot to the side. I don't know. Okay, speaking of Polars, so I have the thing open here. This is the Polar's library. So yesterday I was thinking about this. I'm trying to remember how I got to that point. Okay, so there were a couple of things that happened. Yesterday on stream, I was mentioning how I could maybe write some sort of function, some sort of plugin or something that would help people um, plot tree maps in Rust, right? Initially, my plan was to keep it simple, just use, what do you call it? Just use the tree map RS code that I'd copied and also Tiny Skia. So tree map RS would handle the creation of the data structure and also the manipulation of it, calculating how the rect bounds for each of those map items will make all of the map items fit into the same box. So tree map RS handles all of that, and then Tiny Skia is what we use for doing the actual drawing. So once we have our rect values, once we have the bounds of each of the rects, we can then use any sort of drawing library, because at that point we essentially have coordinates. Um, we have x and y coordinates, and we have the width and height, which is the size. So based on the coordinates and the size, we can kind of determine where the rect is supposed to be drawn, and accordingly we can give our drawing library instructions. And I even did that in Tiny Skia. But then I was wondering if I, instead of using Tiny Skia, maybe I should try doing something in Plotters instead, because Plotters is sort of the go-to library, at least from what I've seen, for doing what do you call it? For doing data visualization, plotting, graphing, and charts and stuff like that. Plotters does give you a bunch of different options. It's highly customizable. It's Rust based, so it's incredibly fast as well. And so that's what I started using then. I I I spent I actually ended up spending a couple of hours trying to set that whole thing up because I ran into some errors and it took me some time to understand exactly why the errors were occurring. But I eventually figured it out thanks to Gemini and some of my own thinking as well. I eventually figured it out, and then I plotted the thing on using plotters. So I was able to set up the tree map plot in using plotters, which is great. So if I wanted, I could write some high level function that's going to be using plotters to do the plotting work. I'm still not entirely sure, but this got me thinking. Now, the reason I'm not entirely sure is because I'm not going to be spending too much time in plotters as much as I would love to. Right now, the reason I was using Tiny Skia to begin with was because I was learning how to use Tiny Skia for another purpose. which is my VTuber application. So I plan on doing like a bunch of drawing stuff, and well, drawing stuff where I'm gonna draw um, onto a pixel grid, and then that pixel grid is gonna be um, that pixel grid is gonna be translated to something that can be that can be displayed in the terminal. That was my idea. That's why I wanted to use something like Tiny Skia, because I didn't want to involve the GPU. I didn't want a whole like graphics pipeline involved. I wanted a library that to which I can give drawing instructions and have it render to a buffer, and then have it give me that buffer of pixel values so I can do something with it. And Tiny Skia does that really well. So that's why I was learning how to use Tiny Skia, and that's why I decided to also use Tiny Skia for this tree map thing, because it became another excuse for me to practice Tiny Skia. So that's why I'm not sure, like if I want to upload this example of plotting tree maps, I'm not sure if I want to use plotters for it or not, because the thing is, I don't use plotters nearly enough right now to be able to how do I say this? I don't use plotters nearly enough right now to be able to comfortably write a high level function to do stuff in plotters. And I feel like if I go to do that right now, it's going to waste a lot of my time. And I say waste a lot of my time because I'm not currently using plotters for anything, even data visualization for that matter. I'm not using it nearly enough or at all to be able to justify spending so much time in plotters. I am going to be using Tiny Skia a lot, so I can definitely justify, you know, uh, creating this entire tree map plotter kind of thing. It's going to be a very it's going to be like a tool built for one specific purpose. That's it. So I think I'm going to stick with that because I'm already comfortable with using that tree map library, and I'm slowly getting more and more comfortable with Tiny Skia, and I'm going to be using Tiny Skia a lot more because again, my VTuber application, I'm working on. Hold on, I just realized I didn't open my stream on my phone, so I don't have my chat open. So let me just open that up real quick. Give me a second here. Okay, all right. Now, what was I saying? Anyways, um, so I'm not going to be using, but okay, all of this being said, like doing all of this, exploring plotters and all, it made me think about how I was doing data science stuff and in general data manipulation stuff using Python. And I was like, okay, what if I tried to do that stuff in Rust? How would that how well would that go? Or how not so well that would go? Um, should I give it a try? And so then I started doing research, and eventually, the research brought me back to this Polars, which is a Rust-based data frame and data manipulation library. Um, I had actually found out about Polars a good year ago, I think. This was back when I was um, learning pandas. At that time, I'd found out about polars as well. And when I looked into it, I was like, okay, for the time being, I think I'll stick with pandas because polars still seems relatively new. And I don't want to be juggling two separate libraries. But then recently, now that I'm doing so much more stuff with Rust and I'm using the terminal a lot more, Actually, the terminal has more to do with the fact that I'm doing TUI stuff, which I guess comes back to Rust. But yeah, all of this stuff made me wonder if I should explore polars. And there's also the fact that I have learned pandas in the past and I am comfortable with pandas at this point. Um, but keeping that in mind, I was like, okay, let me give polars a try now. Let me try setting things up. Let me try doing some data manipulation in it. Give me a second here. So I had a conversation with Gemini about this, and based on all the stuff that Gemini told me, it kind of seems like I do want to give Polars a try because Polars apparently has a slightly different way of doing things. And fortunately, so okay, Polars is it's built on Rust. The engine is built on Rust, and they have a thing exposed to Python as well. So that's why you also have a Polars Python library, which is internally using Rust, the way how Pandas internally is using C, C++, which is why it's so fast. Polars internally uses the Polars Rust library. So I figured that would give me like the best of both worlds. Like I could start by learning it on Python and eventually move that knowledge over to Rust. And in terms of exploring things, because I've had situations where I had to work on like data manipulation stuff, and I had data with me. I had data with me that I converted to. Actually, I don't think I converted it. It was Excel. Yeah, um, it was data in Excel files, and Pandas allows you to read different file types. CSV, I believe JSON. I don't remember exactly. It definitely allows you to read Excel files as well. And so I have done a bunch of data manipulation stuff in and data handling in general, because there have been like, for example, one application that I'd worked on for a family member was where they needed specific visualization. The visualization itself was just a bunch of bar graphs. However, the data to plot onto those bar graphs needed a whole bunch of processing to be done. I had to do a whole bunch of like filtering data. First, I had to like clean up the data, standardize the data, so that, like, for example, if we are talking about months, then we have January and we have Jan. So I had to like standardize those kinds of things into one specific form, that way we have more predictability, right? We know exactly this is what the value is. Then, of course, filling in missing values. That your basic like data formatting, data pre-processing. Essentially, there was a whole bunch of pre-processing that I had to do on the data, and then I had to filter the data and put different pieces of data together to form the actual data that needed to be plotted. So throughout all of this, I very, very heavily used pandas. And I know how, let's just say, confusing pandas can be in this matter, in this aspect. It has its own very specific way of forming expressions and performing operations on data frames and on rows and stuff. And I've done that. I know what it's like. Not saying it's good or bad, but like it can be complicated in some ways. So I was like, okay, let me give polars a try now for a future project. I actually have another future project that I'm going to be working on, which is something finance related. It's a very simple, like small tool for visualizing certain things based on records that the person already has. And this specific tool, I want to try and make it TUI. So I'll use something like Ratatouille, which, gives me another excuse to use Ratatouille because I've been looking for more excuses to use it. And well, my VTuber app is also going to be another excuse to use Ratatouille because yeah, I'm using Ratatouille for that as well. Um, what was I saying? Yeah, so this is Polars, and we're just gonna read this a tiny bit, take a look at some of the examples a little bit, and then I'll see maybe we'll go back to Godot or I don't know. I'll see what I feel like doing. Still not entirely sure because I've been busy. I've been busy doing a bunch of this stuff, and this has got me exploring data science and data manipulation stuff again, but this time I'm trying my best to do it using Rust. I've also been looking into various tools. Let me see what I can. Okay, so I have the archive here. We can go into fake data sets, and in here we have, okay, so I asked Gemini to generate these three data sets for me. Give me a second. Maybe I can um, scratch stuff, empty, temp, data set, fake data sets, and MD fried. Um, oh, it's not showing the, yeah, okay, wait. Let me first of all reset, and then let's open this up in NeoVim. So this is some information that Gemini generated, and here are some of the data sets that Gemini generated. I'm using this application called CSV Lens. Let's open up logistics. What's the first one? Logistics, yeah. So this is some of the data. This is all fake data. This is what Gemini generated for me. I asked it to generate 100 rows for each thing. Now I'm wondering if I should have asked it to generate maybe 500 rows instead. Because now what I'm going to have to do is give Gemini list of this list of rows and maybe some samples, and then have it generate the next 400 rows. Anyways, I asked Gemini to generate the CSV data, and it did. Uh, this is this is logistics, and then we have CSV lens, sensor. There's another one, sensor factory something, sensor factory data. So we have a bunch of data here as well. Basically, I just needed some data um, that I can play around with in, what do you call it? Play around with when I'm learning polars, and I'm going to be learning polars on both Python and Rust. Actually, before we continue, I need to take a short break. I will come back in a couple of minutes. Okay, I'm back. Sorry about that. You know what? I think we're gonna do polars today, and maybe I should change these images. Yeah, yeah. Maybe I should change these images. Um, I can temporarily disable the Godot one and put Python, or replace the Rust one with Python, or I can uh no, I think I'll replace the Godot one with Python. Give me a second here. I'm just changing the image. So we're gonna be learning polars today. I have maybe an hour more to stream. So we will see what we are able to do in that time. Um, okay, so this is taking some time to, what do you call it? This is taking some time to do stuff. OBS is freezing, basically. You know what? Maybe it's not the best idea for me to mess around with the UI because the system might be a bit unstable. Actually, I don't even know if we are still live. Give me a second. Okay. Fortunately, we are still live. It's just that OBS is currently frozen. Yeah, yeah. We are still live. OBS is frozen. While OBS finishes its thing, I can create something here. So, okay, we have logistics, we have sensor factory, we have user. I could, okay, I'll just download all of them. Not download, I'll just copy all of them. Let's create a new thing. Oh, okay, we are back. And now the image thing is popping up. Okay, I need to select Python and then increase the size. And I think we are good to go. Yeah. Okay, so this is our data set. Oh, I can also probably close Godot and disable that capture, so then you can see the um, you can see the thing on top as well. So give me a second here. Let's disable this, and we can also close Godot. And we are back. Great. Awesome. Okay, so I can open up Yahtzee here instead. Um, yeah, we'll open up Yahtzee here. I'll create a new thing. Let's say learning polars. I have too many learning ones here. Let's just say polars. Polars O1. Though one problem I might run into here is that I won't be able to distinguish between uh, Polars Rust and Polars Python. Nah, that's fine. Okay, so in here I want to do UV VNV P 3.13 ENV. Okay, that's done. Awesome. Now we can come here. Now I can actually close this. Oh, no, I can't close this. Wait, I need to... What is this? Oh, temp. Okay. I panicked for a second. I was like, yeah, this is a... These are screenshots I'd taken for, what was it? There was a Twitter post that I'd done about like, this is why I love Rust, and I was explaining the whole tree map and tiny Skia thing, how I accomplished, you know, building the tree map. So, anyways, back to this polars there. So the thing is copied. I can create a new thing called data or data sets. Go in here, paste, and that's our data. And then now we can close this. Let's also clear this, and we are currently wait. Okay, yeah. We need to go back and back and back and back, and then go into polars. Right. So now we'll do UV. We've created the environment already, right? So we need to activate the environment, bin, activate, and then we do UV pip install. Oh yeah, how do we install polars? Hold on. I need to see if there's any specific things I need to enable or something. Give me a second here. We're gonna go back. Let's take a look at getting started. Installing polars. Okay, yeah, we'll start by reading this. So to install polars, we just do pip install polars. And what is here? Okay. So go back, polars. And this has a different environment activated. Let's change that. Source env bin activate. And now in here, wait, is it done installing? Yeah, it's done. Okay. All right. So we can now create a thing here, pi01.py. And save. Cool. Okay, so polars is installed. So we'll do Python 3.13 pi01. That is done. And we are ready to, actually I could, over here, what I could do is, I don't think I'll be needing to create, yeah, just for the sake of having the data on screen, what I can do is cd into this datasets, and then CSV lens. We'll go for the logistics one for now. So this is our dataset. Okay, right. So, what was I doing? Oh, yeah. So we're gonna read this. Actually, isn't there? So this is the docs. We'll read the brochure, so to speak. Polars is a blazingly fast data frame library for manipulating structured data. The core is written in Rust and available for Python, R, and Node.js. Key features: fast, written from scratch in Rust, designed close to the machine and without external dependencies. I/O, first-class support for all common data storage layers, including, not including, data storage layers, local cloud storage, and databases. Intuitive API, you write your own queries. No, what? Write your queries the way they were intended. Polars internally will determine the most efficient way to execute it using its query optimizer. Out of core, the streaming API allows you to process your results without requiring all your data to be in memory at the same time. Sorry, zoned out. Um, it allows you to process your results without requiring all your data to be in memory at the same time. Parallel utilizes the power of your machine by dividing the workload among the available CPU cores without any additional configuration. Vectorized query engine, GPU support, optionally run queries on NVIDIA GPUs for maximum performance for in-memory workloads, and Apache Arrow support. Um, Polars can consume and produce Arrow data, often with zero copy operations. Note that Polars is not built on a PyArrow/Arrow implementation. Instead, Polars has its own compute and buffer implementations. Users new to data frames. Okay, yeah, we know what data frames are. Um, Philosophy. The goal of Polars is to provide a lightning fast data frame library that utilizes all available cores on your machine, optimizes queries to reduce unneeded work/memory allocations, handles datasets much larger than your available RAM, a consistent and predictable API, and adheres to a strict schema. Data types should be known before running the query. Okay, Polars is written in Rust, which gives it C++ performance and allows it to fully control performance critical parts in a query engine. Here's an example. Okay, great. Awesome. So we are going to be learning this. Okay, Polars has a very active community with frequent releases approximately weekly. Below are some of the top contributors to the project. Hell yeah. Okay. Um right. So, next chapter. Okay, this is where we are at right now. This chapter is here to help you. Wait, give me a second. Let me hydrate. Oh, okay. Um, this chapter is here to help you get started with Polars. It covers all the fundamental features and functionalities of the library, making it easy for new users to familiarize themselves with the basics from initial installation and setup to core functionalities. If you're already an advanced user or familiar with data frames, feel free to holy shit. Feel free to skip ahead to the next chapter about installation options. I'm familiar with data frames, but I'm not familiar with working with polars. So I think maybe we should stick with this. Wait, this is similar to hold on, you can provide comments? Wait, do the comments do something? I don't think so. Yeah, no, I don't think the comments do anything. But yeah. I would definitely like to. I mean, okay, a lot of this API, at least the initial stuff that I'm looking at, of course, not all of it is similar. I was about to say a lot of this API is similar to what do you call it, pandas. But yeah, I think it's just the initial stuff that's very similar. But then later on, as we start doing more, meaningful stuff, the API will change because I'm pretty sure the different API is what really makes Polars stand out aside from the insane performance. The different API, the different way of forming expressions and stuff is what makes Polars stand out. So I don't think it's gonna remain the same. I don't know if we should remain on this page or move on to what is the next thing. Feel free to skip ahead to the next chapter about installation options. Polars is a library and Polars is a library and installation is as simple as invoking the package manager of the corresponding programming language. Okay, big index. By default, Polars data frames are limited to 2 to the power 32 rows, which is around 4.3 billion. 4.3 billion rows. That's insane. Increasing this limit to 2 to the power 64, 18 quintillion. Oh, increase this. Okay, you can increase this by enabling the big index extension. Then legacy CPU to install polars for Python on an old CPU without AVX support. Okay, that's a good point. I don't know. Wait, I should ask this question to Gemini. Give me a second. I was opening a tab. I think I jumped the gun. I did, yes. Let's close this. Hold on just a second. Okay. Hey, I'm learning polars, and in the installation options, it mentions that if you have an old CPU without AVX support, then do so and so. I don't know if my CPUs on each of my machines do or don't have AVX support. I'm assuming AVX is vectorized operations, right? Isn't that what it is? Let's open this up. Yeah, advanced vector extensions. So vectorized operations. I'm pretty sure all of the CPUs that I have, they have support for vectorized operations. Let me still ask anyways. So I have, I think they're all Core i5s. Yeah, I think so. I think they're all Core i5s. So I'm just going to say they're all Core i5s. They're all Core i5, but of various gens. One is more than a decade old. Another is close to a decade old. And, well, another is, actually, yeah, another is close to a decade old, and another is around 6 years old. Okay, navigating the world of CPU instruction sets. Navigating the world of CPU instruction sets can feel like a history project, but oh my god! But for polars, the distinction is actually quite simple. Once you look at the Intel release timeline, the short answer: all three of your Core i5 machines almost certainly support AVX. The Intel AVX timeline. Intel introduced AVX with the Sandy Bridge architecture, second gen core, in early 2011. Since your oldest machine is more than a decade old, likely third or fourth gen, from 2013 to 2014, it would still fall safely within the AVX supported era. Okay then. I guess we're good. Okay. Then importing. To use the library, simply import it into your project. Feature flags, numpy fs spec. By using the above command, you install the core of Polars onto your system. However, depending on your use case, you might want to install the optional dependencies as well. These are made optional to minimize the footprint. The flags are different depending on the programming language. Okay, that makes sense. Throughout the user guide, we will mention when a functionality used requires additional dependencies. Okay, all right. Interoperability. Pandas, NumPy, PyArrow. Actually, I'm curious about this. Hey, I'm learning Polars right now and just came across the mention of PyArrow and Arrow. What are these? Okay, welcome to the fast lane. If you're using Polars, you've already made a great choice for speed. To understand why Polars is so fast, you have to understand Apache Arrow because Arrow is essentially the DNA of Polars. Think of it this way, if Polars is the high performance engine, Arrow is the standardized high octane fuel it runs on. Okay, Apache Arrow um, Apache Arrow is a cross-language development platform for in-memory data. Its main contribution to the world is a standardized columnar memory format. Oh, so that's what I'm assuming um, Polars is built on. Okay, columnar over row based. Traditional databases often store data row by row. Arrow stores it column by column. Is that why we have the concept of series? Like you have a data frame, and a data frame is divided into series, where each series is not a row, it's a column. And even when you are like look over here, when you're creating a data frame out of lists of data, you're specifying the data for entire columns, not for like row by row. You create a dictionary, you create a key for each column, and then you specify the data for that entire column. And it's the same here, and here, and here. It's the same. Um, where was I? Oh yeah, I was reading this thing. Uh, this is a game changer for analytics because if you only need to calculate the average of price, you don't have to touch the name or data or date data at all. Zero copy. Because the format is standardized, different tools like Polars, Spark, or DuckDB can share the same data in RAM without having to serialize or convert it. They just pass a pointer to the memory. PyArrow, the bridge. Um, PyArrow is simply the Python library that provides the Python API for Apache Arrow. It's the glue that allows you to interact with Arrow data using Python code. In the context of Polars, you'll often see PyArrow mentioned um, because of interoperability and Parquet files. PyArrow is the industry standard for reading and writing Parquet files, which Polars uses under the hood for some of its heavy lifting. Why this matters to you? Without Arrow, moving data between a database, a processing engine like Polars, and a visualization tool would involve a lot of translation time. With Arrow, they all speak the same language. Okay, I haven't fully understood wait, okay, hold on. I haven't fully understood what exactly Arrow is providing. Is it providing um, a standardized format for representing this data in memory? Well, okay, a standardized format and engine for representing this data in memory. That is a great question. The short answer is Arrow provides the what, which is the format, and also provides a how, which is the engine, but Polars chooses to bring its own engine. To clear this up, it helps to distinguish between Arrow, the specification, and Arrow, the libraries. The standardized format, which is the what. Uh, sorry, zoned out. Okay. This is the core of Apache Arrow. It is a strict set of rules of how it is words. Holy shit! It is a strict set of rules for how data must be laid out in your computer's RAM. Okay, standardization. If you have an Arrow table, a program written in C++, Rust, or Python will see the exact same byte sequence. Okay, all right, for how it is laid out in your RAM. Okay, so how it's being represented in RAM. Then zero copy. Because everyone agrees on the format, you can hand a chunk of memory from a Python process to a Rust process like Polars without actually moving or translate. Oh, is this how we are able to have like a Python layer to interact with the Polars engine? Is that how it becomes slightly easier, slightly more efficient, or maybe a lot more efficient to be able to access the memory from both the Python side and the Rust side? I'm assuming that's how we are able to achieve good performance while even while working on this data that's within Rust through Python. Okay, without actually moving or translating the data, you just hand over the address. Okay, great. The compute engine, the how, the Apache Arrow project does include a set of compute kernels, essentially an engine that can perform math, filters, and joins directly on Arrow data. This is where Polars is different. Arrow's engine, the built-in Arrow compute engine used heavily by PyArrow, is great, but it's designed to be a general purpose toolbox. Polar's engine, Polars uses the Arrow memory format, but it uses its own custom-built engine written in Rust. Polar's authors wrote Polar's how are you supposed to say that? It's one of those situations where it's like you're saying the plural, but then there's supposed to be an apostrophe s after that plural. So then it becomes like you say polars because that's the name, polars, but then you're trying to say something that belongs to polars. So then it's like apostrophe at the end rather. So then it becomes s apostrophe rather than apostrophe s. Anyways, I'm focusing on something silly. Polar's authors wrote their own algorithm for things like joins and group bys because they wanted to squeeze out even more performance through advanced optimization techniques like query planning and parallel execution that the standard Arrow kernels don't always prioritize. Okay. Okay, you know what? That answers my question, and that um, takes care of my curiosity. Where are we? We are supposed to be here. Okay, Excel. Oh, they have stuff for Excel as well. Okay. Okay. Database, cloud, other IO. Okay. Other async. Visualize lazy frames as a graph. Plot data frames using plot data frames through the plot namespace, and style data frames through the style namespace. Okay. All right. So we can come back to this. Why did they say to, hold on. Okay, so once we finish this, does this take us to, oh, this takes us to concepts. This takes us to concepts. What does this do? This takes us to installation. I feel like we should like get an idea through this. So like we'll look at the basics. Okay, reading and writing. Polar supports reading and writing for common formats. Example, CSV, JSON, and Parquet. I hold on. Actually, how do you even pronounce? How do you even pronounce Parquet? Okay, I'm learning Polars. I've come across something called Parquet. What is this, and how do you even pronounce it? Okay, welcome to the world of polars. If you're coming from the standard Python data world, like pandas, you're about to see some serious speed upgrades. Thank you. Good to know. Um, the no, to answer your first question, it is pronounced parquet. Oh, okay. See, I had a doubt whether this would be similar to how like bouquet is pronounced, but then I was like, okay, let me just pronounce it as what I'm seeing. Okay, parquet, like butter, like the butter substitute or the hardwood floor. Okay, what was I saying? Yeah, okay. The T at the end is silent. What is Parquet? In short, Apache Parquet is a storage format designed specifically for big data. While a CSV stores data in rows, like a text file, Parquet stores data in columns. Why Polars loves it? Polars and Parquet are like a match made in heaven because they both prioritize performance and memory efficiency. Here is why you'll likely stop using CSVs once you get used to it. You know what? Yeah, okay, I'm willing to explore this. Columnar storage. If you have a dataset with 100 columns, but only need two, oh, only need two columns. Okay, Polars can skip reading the other 98 entirely. Okay, good to know. This is called projection pushdown. That's what it's called. Okay, so there were two terms that I'd seen mentioned in when I was talking to Gemini about polars. One was pro, what is this called? Projection pushdown, and the other was something to do with predication. I think that's also called predication pushdown. Yeah, that's gonna come up later on. Oh, actually, it hasn't come up in the documentation so far. I don't think so. I think it came up. I think it came up earlier. I don't remember. But yeah, when I was having a conversation with Gemini about polars, it did come up. Okay, Polar supports reading. So wait, no, I was reading the Gemini thing. Okay, this is called projection pushdown. Compression. Parquet files are significantly smaller than CSVs, often 75 to 90% smaller, because similar data types are grouped together and compressed efficiently. Oh, that means, okay, so Parquet then follows a very specific format. I'm assuming it's not plain text. Okay, all right. Then metadata. Parquet files know, quote unquote, know what's inside them. They store data types, such as integers, strings, dates, and even min-max values for chunks of data, allowing Parquet to skip reading parts of the file it doesn't need. Quick comparison. Oh, okay. Parquet is it's binary data. It's not text data. Okay, good to know. This is good to know because I have had situations where I was dealing with immensely massive data. Like, dude, at one point there was, and to be fair, like to my surprise, even that wasn't that slow. It was slow in the sense it wasn't nearly close to real time. If we needed to do this in real time, it would be sluggish as hell. But it was not that slow if you're willing to wait a couple of seconds. Well, no, okay. Truthfully, it wasn't just a couple of seconds. It was, in some cases, it was longer. But the specific thing that I'm talking about was running um, in a Jupyter notebook, which was running in VS Code, which was running on a very slow laptop. So in order to accurately profile this or benchmark this, I would need to do that exact same thing on a system that isn't running sluggishly. So okay, at this point I've forgotten where I was going with it. Oh, yeah, lightning fast. How did I get to that? Anyways, okay. Uh how to use it in polars. df.write parquet, df.read parquet. Okay. Give me a second. Let me hydrate and then I'll continue reading. Oh, okay. All right. Back to this. Dude, you know what? Okay, so I didn't read this part out, but Gemini mentioned this. Gemini said that because Parquet is a binary format, you can't open it in a standard text editor like Notepad to peek at it, quote unquote peek. You'll always need a tool like Polars or a dedicated Parquet viewer to see the contents. This has me wondering if anyone has written a Parquet viewer, um, TUI Parquet viewer. Okay, Parquet Interactive Python TUI. I am looking specifically for Rust. Okay, Tabler. Okay, let's take a look at this. I did not know this was a thing. So I recently, oh, there's also something called Tab View, a lightweight TUI application to view so and so, so and so. I'm just going to open this up. Give me a second. Oh, damn. Okay, Tab View is apparently quite famous and actively being maintained. TabView is a lightweight TUI application that shows users that allows users to view and query tabular data files such as CSV, Parquet, Arrow, and so on. Wait, it says and dot dot dot. Give me a second. This thing froze. Okay. This froze, so I'm going to continue reading while it unfreezes. Okay, wait. It unfroze. It says and dot dot dot. But yeah, okay, either way, I'm glad that I came across this. And I can install it through Cargo. So if I install this, I can test it out and I can see if I like this better than. Holy shit! Okay, there's a bunch of stuff that you can view with this. There's CSV, TSV, Parquet, JSON, JSON-L, Arrow, FWF, fixed width format, SQLite, and Excel. That's crazy. Oh, additionally, you can view multiple files in this. Dude, this is crazy. How did I not come across? Well, okay, to be fair, could have been because I was looking specifically for Ratatouille based things. Though this could also be Ratatouille based. Give me a second. Let me look at the cargo toml file and check the dependencies. Also, what's the other one that popped up? Tabler. Uh, you know what? I like tab view. I'm liking whatever I'm seeing in tab view. Okay, dependencies. Let me just search for Ratatouille. Okay, yeah, it uses Ratatouille. How is it that this didn't pop up, or did this pop up in the list? Because Ratatouille has on their website they have a list of applications, a list of like TUI applications, and they're kind of like promoting the work that people have done using Ratatouille, which is great, which is pretty awesome. And that's how I discovered a bunch of the Ratatouille projects that I came across. Give me a second. Ratatouille um, app showcase. That's what it's called. So let this load up. It's possible that like it was mentioned, but like I missed it. You know what? Yeah, it's possible that it was mentioned and I missed it because tab view is it's T, right? So that might have been lower on the list. Then, of course, there's the amazing Git UI, which I definitely use. Um, hold on. Oh, another thing I installed recently is a tool called MD Fried is a Markdown viewer, a TUI Markdown viewer written in Rust using Ratatouille. And I'll be testing that out soon. I actually found what might be a small bug in the program that I need to report to the repo owner or the maintainers, the devs. I need to report to the devs, and maybe I might try solving it myself as well. I mean, with the same tools that I'm planning on using to solve it, they would also be able to use those same tools to solve it, and there's a chance that they might actually be using those tools to solve. Okay. R is Rainfrog, which is a lightweight terminal based. Okay, this is for databases. Okay. Rucola, an application to manage markdown notes from your terminal and compile them to HTML. Okay. Scope TUI, a simple oscilloscope, vector scope, uh, spectroscope for your terminal. Then Slumber, which is a terminal HTTP/REST client. Steer, a CLI based, okay, Task Warrior. Yeah, I don't think tab view was mentioned. Television was mentioned. That's actually, I believe this is how I'd found television. Television is an amazing fuzzy finder application. Let me show you what television does. Hold on. Um, should I do it in here within this project? Yeah, okay, let's do it within this project. Television, actually, yeah, television with whatever channel, it's going to show us all of these, all of the files that are in here. So this is a fuzzy finder, right? This is a great thing about television. You have something called channels in this. I can, actually, I could, what was the key for, oh, Control T. So you can switch channels. The channels are basically different ways to filter the results, or filter what is being looked at. So in this case, something like files. It says a channel to select files and directories. Then you have text. You have a bunch of stuff here, but you have text, a channel to find and select text from files. So then you're not necessarily looking for files; you're looking for the text within the files, and so on. There's also there's something for Docker images. There's for dot files. Dot files are like config files that you have. It's very common on Linux. Um, Environment variables. This is another interesting one. But yeah, yeah. So this is TV. Anyways, let's get back to what I was reading here about polars. Hold up. How did I get to this? I think I was looking up uh tab view. Yeah, I was looking up tab view. I should install tab view. I should definitely install tab view. Why did my fans suddenly go crazy? Give me a second. What's going on here? Okay, I think we're fine. Right. Coming back to this. So I'm gonna close tab view for a second. I shouldn't close it. I should unload it because I don't want that video constantly playing. The one that's in the repo, and then maybe it's taking up memory or something. Okay, all right. Reading and writing. Polar supports reading and writing for common file formats. Example: CSV, JSON, Parquet, cloud storage, S3, Azure Blob, BigQuery, and databases. Example: Postgres, MySQL, so on. Okay. Below, we create a small data frame and show how to write it to the disk, and read it back. Okay, all right. Import polars as PL, import datetime as DT. What was it? Control E? Yeah. df equals PL dot data frame. All right. Name Alice. Oh God, do I have to wait? Let me just copy the entire thing. Where is the polars documentation? Polars docs. Okay, get started. Yeah, let's just copy this entire data frame. Oh, if I do that, it's gonna, yeah, let's just paste this, and now we can delete this. Oh, that's what that error was. Okay, I kept seeing that error. I don't know if that popped. I think it did. Yeah, you guys saw it in the top right. I kept seeing because yesterday I updated NeoVim and a bunch of the other packages, a bunch of the other plugins, NeoVim slash LazyVim plugins that were installed. I updated a bunch of them, and specifically when I updated NeoVim, then there were a couple of settings that I had to do that I had to change. Well, not a couple. It was like a small thing. It's just that I was doing it for the very first time, so there was a bunch of stuff that I had to look into. And aside from that, I was looking into um, a Rust analyzer related issue that I might have been having, possibly. But yeah, yeah, it wasn't that complicated. Why was I talk? Why am I mentioning this? Oh yeah. After that, I was seeing a couple of like warnings and errors, and I was going through it and fixing each and every one of them. And I was seeing this one. I can show notification history. This is from Lazy Web. No, this is the one I'm looking for. Clipboard error invoking xclip, invalid so and so key. I need to look into this. Xclip is the clipboard program that I use, and generally you have to configure NeoVim because out of the box, NeoVim and even LazyVim, they don't um, they don't they aren't configured to um, write to the operating system's copy buffer. So like when you do like control C, then it copies to that copy buffer. But like NeoVim doesn't do that by default. So you have to configure it to write to that. And the way that it can write to that is by using external programs. So plugins or but NeoVim itself handles it once you do the setting, but you have to do the setting and you have to install the program that's required. In my case, it's Xclip. Depending on what OS you are using, you might have like a different one. But yeah, that's the error that I'm getting here. Okay, anyways, so this is our data. We have name, birth date, um, weight, and height. And then we print df. Now we come here and run this. Missing CPU features. The following required CPU features were not detected. Continuing to use this version of Polars on this processor will likely result in a crash. Install Polars Compat instead of Polars to run Polars with better compatibility. Hint, if you are on an Apple ARM machine, this is likely due to running Python under Rosetta. It's recommended to install a native version of so and so. Okay, all right. Let's. It says what RT compat. You know what? Wait. Let's go to the install options. Hold on. Is that on the next page? Yeah, that's here, right? Install options. No, is it? No, this is concepts, installation. Okay, for legacy CPUs without AVX2 support, I didn't notice the 2 in there. Yeah, I didn't notice the 2 in there. Speed up Rust. No, no, that's not what I'm looking for. Um, okay, yeah, we'll just install. Um, I will need to close this. I didn't install it through this. Oh, okay. Maybe I installed it through this. Right. RT compat. Okay, let it finish downloading and then it'll install. Okay. So now that that's done, I think we should be good. Yes, we are good. And bonus, holy shit, bonus, it's being displayed as an actual table. It's being displayed as a table. That's awesome. Now we can open this up and reload the session. That is not the session I was trying to reload. Oh, does it not have the session here? Yeah, does it not have the session? That's really odd. Why was this specific session not saved? Okay. All right. I mean, either way, it was just one thing. Okay. Right. So we have our data printed. Awesome. In the example below, we write the data frame to a CSV file. Oh, I haven't. Oh, that's next. Okay. We write the example. We write the data frame. We write the data frame to a CSV file called output.csv. After that, we read it back using read underscore CSV, and then print the result for inspection. Okay. All right. You know what? We made some good progress today. We made some great progress today. I'm excited for this. I'm going to continue this off stream. I don't know if the next stream is going to be Godot or this. I do want it to be Godot though, because we are still doing Godot. I'm not just giving up on it. Um, just a second. Oh, there's someone here working on their D&D campaign, I think. You know what? We're gonna go raid them. Yeah, okay. So that's gonna be it for today's stream. Yeah, yeah. I'm excited to get started with polars, and with the knowledge that I already have with pandas, it should be relatively easy to pick up polars and then start doing stuff with polars. And hopefully, eventually, I should also be able to very easily move that knowledge over to the Rust side, because fortunately, they do give us uh, the Python version of the code. Like with each example, they give us a Python version and the Rust version. This is what the Rust version looks like. So yeah, that's that's great. Okay, that's gonna be it for today's stream. I hope you guys have a nice day. And what was I? Sorry, I thought I heard like a disturbance in my fan's sound. So I was like confused. Yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.